Hello, and welcome to Why PLLs Are Cool with Illumination Station. What is a PLL? A PLL is a phased lock loop. It allows one oscillator's pitch to control the pitch of another oscillator through a feedback loop. The principles are fairly simple. Both oscillators are fed into a phase detector. A phase detector can be many things. In this case, I'm using make noise modulation, which could be considered a through zero VCA or perhaps a ring mod. There are various other modules that can be used as a phase detector, including doubly balanced mixers, ring mods, XOR logic. The phase detection can be implemented either in the digital domain with something like a disting, or in the analog domain with something like a modulation. The results will vary, and certain modules like the Dope for A196 provide several different phase detectors to experiment with. The next part of a phased lock loop is a filter. In this case, I'm using maths, which isn't exactly a filter, but it's an integrator which works equally well to smooth out the voltages coming from the phase detector. In the case of the mod to mix, it does not matter which VCO is plugged into the carrier side and which VCO is plugged into the signal side. It works equally well both ways, but experiment with the phase detector that you have and see which one works best. Here's a basic layout of how a phased lock loop works. In this case, I have mod to mix working as the phase detector. I have maths working as the filter, and the two VCOs are the STO and the pure VCO from Glasgow Makes a Noise. Now I've added a sequence to the just to the pure VCO, which is controlling the STO through the phased lock loop. Changing the pitch on the STO works as a timbre control until it goes too far and breaks out of the phased lock loop. Also, depending on the CV that's sent into the controlling oscillator, it can sometimes snap out of lock, creating interesting transients and texture to the piece. From here, there are various creative options that can be taken to affect the phased lock loop and sometimes cause it to break apart and come back together. In this case, I've taken the end of cycle from channel 4, which is the filter, being used in the phased lock loop to trigger channel 1. By feeding this back into channel 4 via the both control, it allows the channel 1 to feed back into the filter of the PLL. I've now taken the sum output of maths and using this as a way to control the PLL, allowing both channels to control the PLL, causing it to break apart and come back together. Further signals from math can be used to control various other elements within the patch. In this case, taking the unity output of channel 4 and controlling the shape of the STO allows for additional timbre control. In this situation, I've taken the basic PLL patch that I showed earlier and used various outputs from maths to control reverb, which has the PLL running through it. This allows everything to move in tandem. Simply adjusting the pitch knob on the STO affects all aspects of the patch. PLLs are an ideal starting point for a generative patch. The beating heart of a woggle bug is based off of a PLL. In this patch here, I've patched a woggle bug, except instead of using a simple sample and hold, I've replaced it with ornaments in crime. Ornaments in crime is acting as a quantizing sample and hold with also a shift register feature. The original, or first, of the shift register is feeding back into the main oscillator. This is the oscillator that's controlling the STO. This means that this is controlling the main pitch of the patch and allowing for melodic and yet random, or at least chaotic, compositions to emerge within the piece. Various other outputs from the ornaments in crime are controlling the reverb and also some other aspects within the patch. The reverb is feeding back into itself to be used as a delay as well as a reverb. The reverb is being controlled both from the PLL circuit coming from maths and also from the ornaments in crime.